Look, I've done my share of dirty jobs, and most of them involve a certain amount of risk. You learn to respect the process, to understand the tools. Now, imagine your job is to pilot a multi-million-dollar tube of metal filled with people, hurtling through the sky at 500 miles an hour. The stakes are a little higher than cleaning a septic tank, to put it mildly. There's no room for on-the-job fumbling. You can't just pull over to the side of a cloud and check the manual when an engine decides to take an unscheduled break. This is where the real work begins, long before a pilot ever steps onto an actual airplane. It starts in a box, the flight simulator. They can learn the intricate dance of buttons, levers, switches that make up a modern cockpit. You can crash and burn a dozen times before lunch and walk away without a scratch, ready to learn from your mistakes and try again. Just like you wouldn't use a sledgehammer to hang a picture frame, you don't use the same kind of simulator for every training task. There's a whole toolbox of these things, each designed for a specific purpose. The king of the hill is the full-motion simulator. This is the big kahuna, the one you see in movies. It's an exact replica of a specific aircraft's cockpit, mounted on powerful hydraulic legs, or electric legs, that can heave, pitch, roll, and yaw. When you're inside one of these, the whole room tilts with you. It's designed to trick your inner ear and your body into believing you are actually flying. Then you have the fixed-base simulator, the workhorse for procedures, and a new kid, VR, plunges you into a fully digital 360-degree world. So what makes a good simulator? It's all about deception. The machine's entire job is to lie to the pilot, to trick their senses into believing they are thousands of feet in the air. Every single control is an exact replica of the real aircraft. Button, switch, knob, lever. They feel the same resistance, hear the same click as in a genuine Boeing 737 or Airbus A320. This tactile reality builds muscle memory. In an emergency, hands go where they need to without thinking. Not grainy cartoons anymore. Modern simulators render a stunningly realistic visual world. High-definition images on wraparound screens deliver accurate airports, terrain, cityscapes, and lighting conditions. The instructor can play God, thick fog, thunderstorm, violent turbulence, creating once-in-a-career events on demand. Behind the curtain of this elaborate stage show is some seriously impressive technology, a marriage of heavy-duty machinery and sophisticated software. The brains are powerful computer models, complex mathematical representations of an aircraft's performance, conceptual, not code. Engineers and aerodynamicists spend years refining these models. When a pilot pulls back on the yoke, the computer calculates lift, drag, and pitch, then updates every system in a blink. The motion platform, the brawn, typically sits on 6 powerful hydraulic or electric actuators. Actuators tilt the cockpit, pressing the pilot into their seat, providing vestibular cues that make the brain feel motion. Graphics engines render terrain, airports, and navigation aids from global databases so visuals match the real world. Control inputs go to the flight model, which tells the motion platform how to move, the visual system what to show, and the instruments what to read. A high-speed feedback loop. This integration is what separates a professional flight simulator from a home video game. Flight simulators aren't just a nifty training aid, they are a fundamental part of the pilot career pipeline from day one to retirement. For a student pilot, the simulator is the perfect classroom to get comfortable with instruments and controls without real flight pressure. They can practice climbs, descents, and turns over and over until the actions become second nature. Repeated practice builds a solid base of knowledge and confidence before facing real-world complexity like ATC or unpredictable weather. To be certified on a new type, much training happens in an exact replica simulator. Regulators allow many credits on the ground because simulators are realistic enough for emergency practice. Pilots take check rides in the sim with an examiner, a pass-fail high-stakes evaluation. Every commercial pilot returns to the simulator every 6 to 12 months for recurrent training, like a fire drill to keep skills sharp. Instructors throw problems at crews to test stress management and team coordination. Post-session debriefs validate performance. Simulators are partners in training, not a total replacement for real flying. Final stage, accumulation of real flight experience. The sim makes that time safer and more efficient. When you get right down to it, simulators deliver 3 powerful benefits: safety, cost savings, and environmental gains. First and foremost, safety. Scenarios too dangerous to practice in the air are routinely trained on the ground. Shut down engines mid-flight, fly into a severe thunderstorm, or practice landing with stuck gear, all without risking lives or aircraft. Flying an airliner is insanely expensive. Fuel, maintenance and wear add up. A full-motion sim costs millions to build, but is cheap to operate hourly by comparison. That lets airlines give pilots many more hours of quality training than they could afford in the air. Every hour shifted from air to simulator is an hour engines aren't burning fuel, a meaningful emissions saving at scale. Multiply by tens of thousands of pilots training worldwide and the savings add up. It's a trifecta: safer, cheaper, and a little greener, a winning combination for aviation. For an industry where failure is costly, the simulator is an absolute necessity. The true value of a flight simulator shines brightest when things go wrong. Pilots hope to avoid catastrophic engine failure on takeoff, or a complete electrical meltdown at 30,000 feet. But hope isn't a strategy. In the simulator, an instructor can systematically dismantle the airplane, simulate engine fire, warning bells, flashing lights, even smoke in the cockpit. Pilots execute emergency checklists from memory and work together to shut down the correct engine and manage the situation. Weather is another adversary. Land a 70-ton jet in a blizzard or a nasty crosswind, and practice it over and over until you know the inputs. Learn how much rudder to apply and how to use throttles to stay on glide path. Hydraulic failures that stiffen controls, cabin depressurization requiring emergency descent, autopilot suddenly disconnects, all practiced in the sim. Instructors can trigger failures at the worst time, like final approach, and pilots must hand fly and use backups to regain control, preparing good people for a bad day. Next time you hit a little turbulence, take comfort. The folks up front have been through 100 times worse, all without leaving the ground.